Electricity is an integral part of today's labs. It's literally everywhere. Without it, operations would come to a standstill. So it's important that we know how to work with it safely. Accidents and equipment problems can cause electric shock or ignite flammable vapors. Performing equipment maintenance or making adjustments without taking proper precautions can result in serious injuries. And sparks from malfunctioning equipment can even cause explosions. So we need to know electricity inside and out. It's the only way to be safe. Let's begin by reviewing a few fundamentals. The force carried by electrical current is measured in volts. Most lab equipment runs on about 120 volts. Equipment requiring large amounts of electricity often runs on specially dedicated 240-volt lines. Current is the flow of electricity. The intensity of the current is measured in amperes, amps for short. The amount of current that an electrical line can safely hold can vary depending on the thickness of the wire. Most lines in a lab can safely carry 20 amps, but some equipment can require a lot more. You may have heard this before, but it's worth repeating. It's the intensity of current, its amperage, not the voltage, that causes shocks. And it doesn't take much electricity to cause serious injuries. In fact, exposure to just 6/100th of an amp, the amount of electricity needed to power a Christmas tree bulb, can be fatal if it passes through your heart. So we need to exercise caution around electricity at all times. Electricity flows when a loop or circuit is completed. A circuit is the uninterrupted passing of electricity from the power source through a piece of equipment and back again. To regulate this loop, machines and equipment have an on-off switch. When the switch is on, the loop is complete and electricity will flow. Moving the switch to the off position breaks the flow of electricity and prevents the equipment from running.
Breaker box system.
As a safeguard, the flow of electricity can also be broken by a fuse or circuit breaker. These can be located within the equipment itself or externally in the lab or a utility room. If electrical wires try to carry more electricity than they can safely handle, they become overloaded. When this occurs, the fuse or circuit breaker will trip, disrupting the flow of electricity.
The power goes out. You come in.
Another important principle to remember is that stray electricity is always being pulled toward the ground. This can lead to a nasty shock if you're in its path. Controlled grounding is what helps to safeguard against this problem. If electricity leaks through insulated wiring, the ground wire will direct the electricity back to ground, not to the person touching the failed equipment. You can see the ground wire easily in 3-prong plugs. But in order for a ground wire to be effective, the outlet that it's plugged into must be connected to the ground as well. So outlets should be tested annually to make sure that they're still grounded. For added safety, outlets can be fitted with a ground fault circuit interrupter, GFCI. The GFCI senses stray electricity by measuring the continuity of the current. If any deviation occurs, the GFCI will shut off the flow of electricity before it can cause any problems. Ground fault circuit interrupters act quickly. This can be a real lifesaver because circuit breakers can't halt dangerous amounts of electricity fast enough to protect you from an electric shock. Following safe work practices is also critical to working safely around electricity. To begin with, we need to remind ourselves that electricity can be dangerous. The 3 most common electrical hazards are fires, shocks, and burns. So you need to be on the lookout for situations that can create these types of hazards. A number of electrical problems involve faulty wiring. Before plugging in a piece of equipment, check the insulation on all wiring for cracks and other defects. Report any problems and have faulty wires replaced or serviced immediately. Don't overload circuits by plugging too many pieces of equipment into outlets or power strips. This can cause the wiring to heat up and increase the risk of a fire. Try not to use extension cords. Eventually, the cords will develop cracks and other defects that can lead to shocks, and these problems can't be covered up with electrical tape. Some accreditation groups such as JCAHO and CAP prohibit their use. So play it safe and position your equipment within easy reach of an outlet. Always use caution when selecting electrical lab equipment. Whenever possible, it should be double insulated. This provides built-in protection against shock. With double insulation, a special safety shielding conducts stray electricity away from you to the ground wire. Sometimes equipment may appear to be working properly, but closer inspection will reveal a problem. For example, a machine with damaged connections can occasionally spark. It could initially look like it's fine, but actually be a real hazard. Be careful. Electrical sparks can ignite flammable liquids, vapors, and dusts. Tell your supervisor about any problems and contact a qualified repair person. Don't try to fix the equipment yourself. If you need to get inside a piece of equipment to make an adjustment or perform routine maintenance, disconnect all its power sources before opening it. Make sure to use proper lockout-tagout procedures as well. Consult your supervisor if you have any questions. In areas where flammable materials exist, it's especially important that you choose the equipment you work with carefully. Motor-driven electrical equipment should be equipped with non-sparking motors and switches that limit the possibility of an accidental fire. This includes items such as vacuum pumps, mechanical shakers, and stirring devices. Never bring home appliances into a lab where flammables are present. Most of them have switches that can spark. Maintenance crews often bring vacuum cleaners and power tools into our labs. Their motors can create sparks as well. So before this equipment is used, make sure that the lab is free of flammable vapors. Water and other liquids are another thing that can create real problems when electricity is around. So you need to prevent them from coming in contact with electrical equipment. Liquids can damage sensitive electrical circuits and leave you vulnerable to a shock. If, despite your best efforts, something goes wrong with electricity in your lab, it's important to be prepared. Never touch a person who's in contact with a live wire. First, cut off the electricity, then immediately call for emergency medical personnel. Because of the heat generated by electricity, electrical accidents often result in fires. So fire safety can be very important. Know the location of fire extinguishers near your work area. Electrical fire should be fought with Type C fire extinguishers. Most labs use ABC extinguishers, which will work fine. But if a fire is too much to handle, get out and leave it to the professionals. A working knowledge of first aid can also be very helpful in case an electrical accident occurs. Cover minor electrical burns with loose, dry, sterile dressings or bandages. Make sure that the victim gets medical attention to prevent any complications.
We have a medical emergency.
Since electrical accidents are often serious, victims may need CPR or treatment for shock. While many lab facilities have special CPR teams, it's also a good idea to learn how to administer CPR yourself. Ask your supervisor about any training your lab may offer. Electricity is a valuable asset, but we need to know how to use it. Let's review. Know how electricity works. Select electrical equipment carefully. Always follow proper electrical work practices. Report any unsafe conditions like sparking or cracked wires. And be prepared in case of an emergency. Electricity makes our labs more efficient. It's up to us to make sure that we take all the necessary precautions to work with it safely.